kick you guys out. Not today, but for next time. We'll just sleep late. Let's see what we got. Okay, let's see. Is Mary back there? Yes, she is. Are you okay? I was like, I thought you were here and I'm going to see you. Sorry, I'm just trying to double check. There's Jacob. Okay. We have a few people just wandering in. Come on in. Let's see. Who am I missing? I can't tell. Des. Not to Marianne. Chelsea. How's it pretty? Yay, how's everybody this morning? We do some queries. I'm going to share my screen and we're going to do those assignments. We have some people that have gotten them done on their own. Good job. But before we do that, let's do some practice queries. So let's use our SQL Server Management Studio. Mine's on the slow open. I think it's thinking about it, but I'm not sure. Oh, there it goes. Must have had to phone home or something. All right, and I want to connect to our CIS250 server. So I'm going to use my drop down and make sure that I'm on the 250 one for those of you that are using the other server in your other class. And then I'm going to enter in my password stuff. And last time, whenever we logged on, I showed you how I usually go to my database, and that whenever we open a database like that, just by clicking on it, that becomes our current database. It's kind of like if you're working with Windows or a DOS folder and you're sitting in the folder, you can run programs and stuff from that folder because it's your current folder. We have a current database in the same way. I'm not missing too much of the screen there, are we? So to do some examples though, let me find my document that I had here. Too many things open. I wanted to try some examples and I wanted to use some joins so that we could see how they work a little bit better. So I want to find the database that has the vendors and invoices tables. And I know in Canvas, if I go to the modules section, I have this Guitar Shop ER diagram in color on our setup. Take a look at that. So we're going to be working with the database that this one kind of defines. And we want to focus on this area where we have products. And for each product, we can have people who order that product or customers that order that product. If they order that product, it'll show up on an order items table row. And those order items table rows are created whenever we create an order. So our orders just give us the information about who made an order from us. Our order is associated with the customer that made the order. So we have these connections here. Our customer's primary key is customer ID. Our order's primary key is order ID, but it has a foreign key to relate back to the customer that made the order. So we can see, looking at this diagram, the different connections. So the database is aware of those connections as far as enforcing that referential integrity. Remember, it's not going to let us create an order unless we specify a valid customer ID when we create that order. So it's going to keep those rules in place, but it's not going to use those relationship rules in the way necessarily that we want it to join our data to give us output. So we're going to use our join syntax to make that happen the way we want. So I'm just going to minimize this because I'll probably want to come back to it. Maybe I'll just kind of slide it over to the side a little bit if I can keep it. And then in my SQL Server window, it's huge. Slide it over a little bit. I want to make sure I'm looking at the right database. And I'm not sure if those tables are in the AP database or the My Guitar Shop. So I'm going to check My Guitar Shop first. And if I look at the tables, this one has, yeah, products and orders and those kinds of things. My AP database has invoices and vendors. So let's look at it first. So I'm going to just click on the AP database to make it my current database. In my queries, I'm still going to put that use statement So let's create a query. First thing I want to do is put in my use statement, use AP, and then go. And looking at the database, I can see that I have invoices and vendors. If I look at my pictures, vendors are the people we buy things from, where customers are the people we sell things to. That's basically the difference between a vendor and a customer. So we're going to see a lot of the same information. But I'd like to get familiar with that data, so I could just say select star from vendors, because I don't know what kind of vendors I have in this table, and I might as well get familiar with them. So when I do that, remember that select star statement is giving me all of the columns from the vendors table. So if I look down at my results set, I'll see everything that's in that table. So I can kind of do that just to get familiar a little bit with what my data looks like, because you know, a different company might have different kinds of data that they're keeping track of. Every company is going to keep track of vendors, the people that they buy things from. They might call this table supplier or something, some other sort of term like that, but it's going to be their vendors. So what do we have? Normal information, an ID that we've assigned to be a unique primary key for our vendor table. We have their name, their address information, city, state, zip, phone number, all those kinds of standard things we would need to keep track of for a company that we do business with. If we look a little further, we'll see that we also have a default terms ID, which means how this vendor expects us to pay, like within 10 days or 15 days or 30 days. We can have different agreements with different vendors. And then what account number in our accounting system we would automatically apply money to that we pay this vendor. So some different pieces of information for us. What about our invoices table? I see our invoices table here. Let's select everything from it and see what kind of information it contains. So here we go with our invoices. We see we have a vendor ID for every invoice. Who do we buy this from? We can't have a bill, which is what an invoice is, unless we have a vendor that we bought it from. So even if we bought stamps from the post office, we're going to have them out here as a vendor, and we're going to have a vendor ID for them. But we have this fancy invoice number, but that's not our primary key, is it? For our invoices, we've gone ahead and assigned an invoice ID that we assign sequentially, like our other ID fields, to make sure we have a unique key for our invoice table.
All the invoice numbers are so different.
Right, they're all so different, and we wouldn't be able to know for sure what to find there. We could end up with a duplicate by accident. And then we have dates and how much money the whole bill is for, and different pieces of information like that. So that's how our data sort of fits together. You guys could think about how a database would, you know, what kind of data would be contained based on all of the different databases that you've designed, because you've created so many designs. You've seen what kind of data they would have. So we could look at invoices for all of our vendors if we did a join. So let's say we want to do that. We're going to select just a few columns. We want the invoice number, and let's get our vendor name. So we don't want to select a whole bunch of them because everybody's already good typers. And we're going to select these from our vendors table. So that means when the database starts accessing data, it's going to start at the vendors table. It's got to be in there somewhere, but I'm not seeing it, so I'm just going to minimize that. So it's going to start at the vendors table, and it's going to pull basically all of the vendors, and it's going to keep that vendor name for all of our vendors. That's not going to give us any information about invoices. We're going to have to do our join. What we have to do is join our invoices table. And we have to tell the system how to make that connection. I'm trying to press enter and it's not letting me. There we go. We need to make that connection on the vendor ID. So the vendor ID on our vendor table. So I'll put our table name first, vendors.vendor ID, being equal to the vendor ID on our invoice table. And when we looked at our data, we saw that because we see that every invoice, again, has that foreign key that points back to the vendor, the supplier that we bought this stuff from. So let's run that query. So now we've got our vendor name, but we also have the invoices for that vendor. Let's switch it, because notice how they have things kind of in a different order. In our from clause, our left table is our vendor table because it comes before the word join. Our right table is our invoices table because it comes after the word join, right? Left of the word, right of the word. It's super fancy. But up here in our select statement, our columns are in the opposite order. And I think that makes it confusing for us. So I want to switch them. So let's say we're going to select vendor name, then invoice number. Let's run that. And it's no different. Our data is no different at all. We're getting the exact same data out of this query. We just switched the order of the columns so that the data output would logically match our join so that we could see what's happening here. Because with it switched the other way, it was kind of hard to tell. But now we can tell. For every vendor, we're seeing their name. Because we said, I want to join the invoice ID to the vendor invoice ID, we're also getting the invoice number associated with every invoice for that vendor. So this join, notice right away, we're getting duplicate vendor names, right? Because every vendor could have more than one invoice. So that's our join is taking care of that, is allowing us to get those duplicates. Hey, you. Let me fix our time. So we're getting that data. Des will get you in here. Let me find my attendance here.
Sorry, I'm just extremely stupid.
You what?
I'm just extremely stupid.
Were you sleeping? That's good.
No, I thought today was Wednesday.
Uh-huh.
I went to work.
Oh, no. They kicked you out. We don't need you. What we're doing, we got into our SQL Server Management Studio, and we're looking at some joins, just some example joins, using the AP database, our example database, so we could kind of get an idea of how these things fit together. So go to your SQL Server Management Studio and open it. And then get our selects going. Okay, so this is a standard join. I'm going to put a couple comments on here. So we'll gather every vendor row, then every invoice row, then match the two results by invoice number. I put that on there because I want you to always be thinking about the performance aspects of the select statements that you're doing. So if we have 40 million invoices, that's going to be a lot, but that's what we have to do sometimes. All right, so that's our first join. Let's save it. Let's do file. Save as. And then I'm going to go to my CIS250 folder. It tries to save it in an SQL Server Management Studio folder, but I have my own. And I'll just put that this is examples. And I'm just going to call this my first join, even though we've done some other joins. We hadn't saved them. So we'll focus on looking at our AP database here just for a second. All right, so whenever you do a join like this and you go to W3 schools and other places and you're looking for help, the first thing you're going to see are all sorts of different syntaxes where they say as A, as B, as Q, as Z. Everybody loves using those synonyms or correlated names. So we can make this query use correlated names. Let's copy it and click on new query and then paste. So we're going to add to this one, use correlated table names, synonyms. So I can do that. We saw earlier that we could put as some name, like if we were calculating a column and we didn't want to leave that column name blank, we could specify the name. Well, when we're doing a join, we can do that with our table names. So we could say that we want to select, let's make this bigger. We're going to select invoice number. I'm going to put a whole list here. And then we want vendor name, invoice due date, and then we're going to create a calculated column. Invoice total minus payment total minus credit total. Now, when we were looking at designing databases, we saw that values like this, calculated values, this outstanding balance is basically what we're calculating here. These are things that we don't want to carry permanently in our database, right? Because it can be calculated. So since it's something that can be calculated, we might end up calculating it a lot in our queries because we don't have it on our database. Now, why is it mad at me? Let's see. I'm going to say that I put something wrong there. Instead of that, I want to say as balance due. So now I'm saying, give me the invoice number, the vendor name, the invoice due date, and then the balance due on that invoice. And the balance due is going to be the original amount minus however much they've paid and however much we gave them as a credit. We might have said, oh, you can have a little bit. All right, so that's the columns we want. Now in our from clause, we can say from vendors as V and give that table a short name. And then we can say join invoices as I. And in our on clause, we can use that short name. Take it a second. And now we've just kind of shortened our query. So the reason that developers do this is sometimes their on clause might be quite long. They might have several fields or columns that they need to match to make this join occur. So they can use these kind of correlated names, shortened names, to kind of eliminate some code. Now with our query, we can run this. Let's go ahead and run it this way. We should see for every vendor, IBM, each of their invoices, and that invoice due date and balance due. Now, if we look through, we see a lot of invoices that are all paid. The balance due is 0. So let's say our management comes back and says, well, this is a great query. Could you eliminate all of these that have been paid? So we could add a where clause. I'm going to put that right here before our closing semicolon. And remember, our where clause is going to restrict our result set. So in our where clause, we're going to say that we want all of the ones that don't have 0 for that balance due. So I'll say where balance due greater than 0. Now, what I want to see is, will it let me do that? Because remember, this as keyword is just temporary. It's just a synonym, and it's creating this column name temporarily. And sure enough, I can't use it in my where clause. It's not real. It's only transient. So what I have to do in my where clause is duplicate this formula. And oftentimes, people can't believe that it's that dumb, but it is. Okay, so that should get rid of all of the ones that are already paid. Let's run it. Oh, that really shortens that list a lot, doesn't it? So you can see why that would matter to our managers. And so they like that, but they come back to you and they say, is there any way that you could put it in order so that I know which ones are the oldest? Let's do that for them. After our where clause, we can add an order by clause. And in our order by clause, we can say, well, let's order things by the invoice due date in a descending order so that we see the newest ones at the top. Did I say that right? Let's run it and make sure. Yeah, because they're all from 2016, so it's hard to be sure, but yeah. So we're seeing our newest ones. And our management would probably want the oldest ones on top, but then we wouldn't be able to have an example of making that order by clause descending. So here is this select statement is a really good example because it gives us an overview of our main select clauses. We always have select and from. We always have those. After that, we can have a where clause if we want to limit our result set, and we can have an order by clause if we want to sort it. Can you make those be in any other order? No. If you switch them around, you're going to get an error. So they have to be in that order. Those are really, really good test questions, right? Because people who make tests love questions where there's an absolute right answer. And those have to be in that order. So we can't do it any other way. Tons of good stuff. Let's save this query. This one, we'll say correlated join. Correlated simply meaning I'm giving the table a temporary name. Now, the point of this one thing that is important for us to notice is that the as stuff, the correlation, can kind of make the query harder to read. So that's an older standard that people preferred, but it's kind of fallen out of favor. But you will see it on a lot of documentation sites and things that you look at. Now, let's see if we could do it in a way that would actually make things better. Let's open a new query again. So I want to use the AP database. And this time, I'll put my from clause in so it can, IntelliSense can help me. I'm just going to put from invoices. There's going to be some other things I'll have to figure out on my own. So in my select clause, I want the invoice number and the invoice line item amount. This is coming from our table we're going to join to, so we'll have to type it all the way out. IntelliSense is not going to be aware of it. And one more column, invoice line item description. So in our from clause, we know that the primary table we want to access is our invoices table. But just like our database that we were looking at before, let me try to bring up that picture again. Oh, I've messed it up. Anytime we're looking at invoices or bills, we're going to see those line items, the individual items that we've purchased. So in this diagram, here's our invoices down here. If I can zoom in, our invoices have these invoice line items, and those are the individual items on the bill. So if our invoice was to city utilities, for utilities, then some of the line items might be electricity, sewer, different things like that. If I was buying something from Office Depot, then my invoice might be Office Depot. My line items might be Post-it notes, printer paper, things like that. So the line item is going to be each of the things that we bought. In our line items, we've got a primary key that's a combination key of our invoice ID and an invoice sequence. So we're going to use both of those columns together to create a unique primary key. So that means for invoice number 1, I'm going to have sequence number 1, which is electricity. Sequence number 2, sewer. Sequence number 3, water, those kinds of things. So that's what we're expecting to see in our line items. So we want to join those. So for our invoices, let's join our invoice line items table. And how do we want to join those? On our invoice ID. So in our invoices table, we have invoice ID. And in our invoice line item table, we have invoice ID. So we're just telling the database management system, this is my primary key and foreign key. This is how you can match these two to know that they belong together. They belong with each other, because otherwise it wouldn't know. So let's run that. That's great. But let's think about how we could actually simplify by using a correlation name. This invoice line items table name is so long, we could actually just call it line items, and then we could really shorten our on clause in a meaningful way. So whenever you're using those correlated names like that, they can give you a lot of power, because remember, if I were making this join connection on invoice ID and invoice date and customer ID and some other fields, then I might be repeating that code over and over, so I could make it shortened. All right, does it work? That one looks good. What if we only want to find invoices that are going to our account number 540? We could add a where clause, where account number. So remember, we saw that on our invoice table. We know that we have that account number field. We could say where in account number equals 540. Now, account number, notice, is not one of the columns that we've selected on our select statement. That's okay. Our where clause can include columns that are not part of our select statement. So we're going to run that. Now, when we do include that in our where clause, the internal table, the internal result set that's being built for us is going to have that account number, right? Because it's going to have to keep that in its internal tables to run this where clause. But then when we see our final result set, we won't see it. Go ahead and add code then to sort that by invoice date. We would just do order by invoice date. And now if I run it, I should have that. And of course, again, that's a column that we're not selecting. So we don't see any resulting change in our output other than the sequence. So we have to, in that case, kind of assume that it did it. So often when we use something to order our output, that'll be a column that's shown. But this just goes to show you it doesn't have to be. Now, when I look at these table names right now, this is just a local name. So this invoice table is part of the AP database in our SQL server. So if I were accessing a table that were off on some other server in some other database, I could do that. So I could specify always before the database name, DBO for database owner, and that's kind of a syntax thing. I could put my guitar shop .dbo.invoices if I wanted to fully qualify that table name. I could even put the server name before that database name if I wanted to. So that's why sometimes this as clause, the correlation name, again gets super important. If I'm having to use a fully qualified table name that starts with my server and then the database and then .dbo and finally my table name, that can get very, very long. So the as keyword to give it a correlated name will help that. So if I'm a company that has locations all over the world, I'm probably going to have a lot of different servers in different places, or even different Amazon web servers that I have different database tables stored on that I want to be able to communicate with. So that is a fully qualified name. Let's add some comments there. Join the invoice to its line items for a given account number. I've got to get rid of all of my fully qualifiedness stuff. We'll put a comment in there. Fully qualified table name would be equal something like server, whoops, server name dot database name dot DBO table name. So we can have partially qualified, fully qualified, just depending on what we're working with. As far as our databases are scattered across the country, that's what we can name them. Let's save this one. So we'll call this fully qualified name. And I'm going to add invoice line items join, just because I think that's something that will come up again later. And now it's all saved and all happy with us. Now, I'm going to add another new query and just one more example. If I can type right, I want to use the AP. Type it all today, go. And in this query, we want to get some information from our invoices and each of the line items on an invoice, but we're going to use more than one column to create our join, because our on clause is going to have more than one criteria. So let's start our select statement. We want to select, and I'm going to put from invoices join invoice line items. So the more of my from clause I can put, the more IntelliSense will be able to help me. So I want my invoice number and my invoice date and my invoice line item amount. And invoice total. Now, when I join my line items to my invoice, I of course want to use my invoice ID column, invoices, invoice ID being equal to my invoice line items, invoice ID. Because that would be my primary join. I'm just going to type that all the time. And you can tell that that's why I use IntelliSense, because you know, you get really good at typing and you get tired of it. So we've got that join, but we want to do something else. We want to add an and clause. We're going to say that I also want to meet another criteria. On my invoices, if the invoice total, there it is greater than the invoice, oh, I want to do that as clause, call this line items, make it a little shorter. I was being all long and typing too much. So for these line items, I want to look at each of the line item amounts. And so what I'm doing here is kind of a weird query, but I'm saying that I want all of the invoices and give me each of the line items. And then for each of those line items, I want to know if that one line item is less than the total of the invoice. So we must buy a lot of things, a lot of invoices where we only have one thing, right? Now let's run this. I'm going to put a semicolon on there. So here I've got, for this invoice, I bought multiple things, 4 things. For this other invoice, I bought 2 things. It seems like a weird query to me. I'm not quite understanding. So I could comment those 2 lines out, right? Do some troubleshooting, put my semicolon here, get rid of that and, should have been on the next line anyways, and run this and see what happens if I don't have that criteria. $6, $6. Yeah, we do have a lot of invoices where we only buy one thing. So that's interesting. And that's just our data. Again, we can look at the data for an individual company to see specific things like that. And that's why companies like to keep the people that they have working for them, you know, because they know things like that, that, oh, we have this weird anomaly in our data. Now I'm going to run it again. No, we only have 2 invoices where we have purchased more than one thing. Jackie's got, will we be learning how to round numbers today? We'll have to find it. We shall see. Okay, so that's some good join criteria. I would like to order this one though. On this one, could you add in a sort to sort it by invoice number? And then let's save that. So I would just add my order by clause. Run it. And then I can save it. And we'll say join with 2 conditions. And then let's copy this. We're going to change it just a little bit. Copy. And create a new query and paste. And what I want to do here is change this and to a where. Can I do that? Is that legal? Let's try running it. We get the same results. So there's more than one way to do something correctly, right? So in this example, instead of having both of those criteria in our join, we created our join and then had our where criteria is separate. Do you prefer one way or the other? It's kind of a matter of preference. It should be okay to do either way. Let's save this one now. Easy peasy. This one was join with 2 conditions as where. So that's some good join stuff. That should get us going through a lot of those problems that we have to do for the Cengage thing. There are 3 or 4 that are in our listing for today that include summary queries, and we haven't talked about those yet. So when we get to those, we're just going to do those queries together. Next time we'll talk about them and do some samples and examples so they'll start making more sense for the additional 100 or so that we'll do later. Okay, I'm going to save this, or at least minimize it, and go to Cengage. Yeah, I'm still here. I'm always so happy when Cengage has maximum security for me. Okay, so remember we're looking at our code issues thingies instead of apply. I got us used to that and then switched it. And I'm going to go into this very first set of problems. Now, as it's loading, in my OneNote, I'll set these up so you can copy some things. For our Chapter 7 tab, I went ahead and added some additional pages. So create a page for the construct co DB, and this isn't the best ER diagram, but you can snip it off the Zoom session if you want to grab it. You can also get it from the textbook and all of the other places we have it. I opened Access and kind of built it from within Access, so it could be missing some pieces, but I wanted to have each of these different ER diagrams available as we were working through these so that we can look at the pictures. So that's the construction company one. That one we've already all got created in our database. We've got these tables created out there, and this is the one that we worked with a little bit so far. The reason it's a construction company, it has the job entity. So think about it that way. It's a construction company. They do their work in jobs, you know, like the job to redo this bathroom or to redo this floor. So that's why the job code has, you know, all the different entities that it has for keeping track of which people have been assigned to that construction company job, which employees. Now let's look at the fact DB, and you can get a copy of that one. It's a little small. But for this, do what?
Where's the stuff at?
Oh, on Zoom. It's in my OneNote notebook, so I figured you could just do a screen grab off of Zoom. I'll bring that other one back up when you get there. So in this one, it's kind of neat because they just did it like, you know, an author writes a book. So they made that join table actually be kind of the process name. That's kind of a neat way to design it. So we're sort of a library system here. We have books that people can check out, and our customers are patrons. And my daughter says that all the time, you know, because she's a library person, so it's hard for me to remember that they call them patrons. So because they're not customers, they don't buy things, right? They just use things. So that's why they're patrons. So our fact database is a library. And we want to go ahead and create this one. We'll get it created in our database. Now, large co, if we look at it, large co, we could call them like poor design co, right? No sort of relationships in this database at all. So we'll see what's going to happen with it. I don't know what kind of queries they're going to have us use, but all of our entity names at least have a prefix. So we don't have to worry about overwriting our other tables. We can keep them all separate in our one database. So everything from this large co starts with LG. So if we see any queries that have those tables in it, we know it's this large co. And you can tell they're kind of like the AP database that we've been working with, our sample queries, because they have a customer and vendors and products. They just don't have any sort of relationships between them at all. So kind of a mess. Now, Saleco, they obviously sell things. And they have, again, products and vendors that they buy the products from, and line items for each of the invoice items that they purchase, and customers. So this one's interesting. This one does have relationships. Let's get those all created. Do you guys have your Chapter 7 syntax? I'm going to go to my database. Sorry, I'm jumping around. I want to go to my Riley RE database and look at my tables. And right now, I have the tables created for customer amp invoice. So construct co, is that right? think I have a merge, a mixture. Let's come back to that. Minimize SQL Server Management Studio, and we will do that next time. So what I want to do is we'll get all 4 of those different databases created in your SQL Server Management Studio, so you can do any of the sample queries that you want to do or anything like that. Now, one thing that I did add to Canvas before we ever get all these things done is dangerous queries. So let me see if I can get there from here. I am super zoomed in. So in week 9, our lesson 9 stuff, dangerous joins. We had left last week with all that confusion because our book was talking about these natural joins, and I was like, what? What are they talking about? Well, they were talking about really, really dangerous ways of doing things. So there are basically 3 syntax types that can be dangerous. And our textbook, in a blaze of glory, decided to tell you about those first. So we're okay, we can recover from this. First of all is the natural join. So if you look at that join document, it's down at the very bottom. Here's the syntax. So whenever we're working with a natural join, we're going to start out with select columns from table, and then that keyword natural and the word join.
We don't have access to that.
You don't? Let me fix that. Thank you.
You have to complete the items first.
Well, there's also a place that you
Where are you looking at? You still have access to it. Using joins? Are you needing to complete some stuff above that?
Oh, okay. Mine's being screwy.
Is it? I don't know if there's any way I can eliminate those things. Get them all completed.
Well, Canvas wasn't updating it properly.
Tell me about it. So keep working at getting to it, and I'll post it to Discord. Oh, Discord isn't running. That's why my life is so much better this morning. Sorry, just kidding. Haha. I will send it to you in Discord. But you got to get all those silly things completed. Okay, you should see it in our Discord. The natural join. Whenever we were talking about joins earlier today, I said the database will pull every row from the first table, all of the columns you selected, and then every row from the second table, all of the columns you selected, and the join columns, and then match them. Do this little match game and give you the results. So what a natural join does is it lets you not put the on clause. You don't have to say what columns to match. The natural join will go out and figure it out. So it'll say, oh, both of these tables have invoice IDs, so I bet I need to join on invoice ID, and it'll do that join, and that's all good. So it can be really handy because it'll take care of that. But it'll join every column that matches on the table. So what if you have a column called change date? Will it use that as a join column? Yeah, because it's the same on both tables. Or you have a column like total due that happens to be on both tables. Now it's going to use that column to join because it's named the same on both tables. And remember, naming columns the same because it's the same thing is something we want to do in database design. We don't want to give them different names. So the natural join is terribly, awfully evil, evil, evil. That's why when we searched for it the other day, I was like, you can't even use it on SQL Server. Oh no, what are we going to do? No, that's good. It's a good thing because we don't want to do natural join. So a natural join would pick every column that matches, that occurs on both tables, and try to join using all of those columns. So the first time it's going to scan table 1 and table 2 to do the first join. And then it's going to scan again for that extra column to do the second join, and then scan again to do the third join. And we could end up with something that takes a really, really long time to run and produces a bunch of basically garbage because we can't have all of those different join columns. So natural join exists only within a couple of database management systems, and it's discouraged. It's basically out there for brand new developers who don't know how to use join syntax and should not be used. Going up then from the worst to the least worst, the next syntax that they presented to us is this using syntax. So in the using syntax, instead of saying natural join, we are saying join, but instead of saying on this column, we're going to say using and then a column list. This syntax is fine. It's basically exactly the same as the on syntax we are using. It's just that it's only accepted by certain database management systems. So you might see this using syntax. It really threw me. It's not something that I'm familiar with at all. So it was like, what in the world are they doing? But it's fine. It's just another way of saying on this column, on that column. But if we use the using clause, our column name does have to be exactly the same on both tables because we can only specify that column name one time. So we could say using vendor ID, and that would do that join like we were doing. So using exists not in all database management systems, so it's not an SQL standard, so it's something that I would stay away from. The top one is called an implicit join. This is the one you're going to see out in the wild, wild world a lot. The implicit join is the old school join, and it's done by just listing tables. So it's really handy because I can say select column list from table list where this column on table 1 equals this column on table 2, and this column on table 2 equals this column on table 1. And I can just specify my on clause basically in my where criteria. So this kind of join is super handy, and you'll find it on W3 Schools and other places being suggested to you, but it's not okay. It's an implicit join. The database management system now is going to decide which table to start with and how to access that data and how to make that connection. So in a lot of cases, you're going to come out with the exact results you expect. In a lot of cases, you're not. And we can have a lot of churning and working going on behind the scenes. So no implicit joins, bad, bad, bad. No using joins, not as bad, but just not widely accepted. And no natural joins. So yay, new textbook to show us those first. And I'm like, you guys will remember them now. Don't ever use them. Just what you always want to do. Okay, so we got that. We know what to do about those evil joins. So most of the joins that we're going to see are going to be using this on clause like our example was. So problem 2 is a doozy. Let's start with it. Now that I finally did all my talking, we have employee, job, and project tables in our ConstructCo database. We want to write SQL code that will join the job, employee, and project tables using common attributes. Display We've got this one done already, right? Display the attributes shown in the results presented. And in this one, what we did last time is we got our column list of all of the columns that they wanted. And you guys were super observant and noticed they had to be in the same order in our select clause as we wanted our output. And then in our from clause, we started with our project table, because if we look at our construction company database, our project table was what they were wanting, right? They wanted a list of projects. So usually based on our criteria, we can determine what our starting kind of table should be. If we want a list of projects, our projects table should be our first table in our from clause. Then based on that project, we said we can join a project to an employee based on the emp num. So that would be like, I guess, our project manager. And then from our employee, we can join our job based on the job code, and we got our results out, and then we put in our order by clause to make everything good. Okay, so problem 3. Write the SQL code that will produce the same information that was shown in problem 2, but sorted by the employee's last name. Can I just order by something different here?
Yes.
And underscore L name. We probably could have done that last time, huh? Good job, you guys. All right, problem 4. Write the SQL code that will list only the distinct project numbers in the assignment table, sorted by project number. Okay, so let's get started here. First of all, I want to select, whenever we're working with keywords like distinct that have to do with limiting our column list, they're going to come right there in our column list. So we want a distinct list of project numbers from our project table. Oops, nope, assignment table. Now, can I run that? So I'm getting 15, 18, 22, 25. We didn't need to do any sorting or anything. Looks good. All right, problem 5. We've got here, we want to validate the assigned charge values in the assignment table. So your query should retrieve the assignment number, employee number, project number, the stored assignment charge, and the calculated assignment charge. And we're going to do that calculation by multiplying the assignment charge hour by the assignment hours. And we're going to call that calc assigned charge, and round to 2 decimal places, sort the results by the assignment number. That's why Jackie was asking about rounding, huh? She's on it. So let's get started here. First of all, I want assigned number. I'm just going to be looking at that column list. Amp num, proj num, assign charge. And then we said we wanted assign charge hour. times assign hours as calc assign charge. Now we need to sort the results by assignment number. Assign underscore num. Now, whenever you're looking at these problems, these can be the hardest thing for people. So it's kind of like doing a word problem in math, isn't it? Because it's giving you all these different pieces, all these steps. So a lot of people over the years have liked copying the requirements into their SQL code and kind of, pressing enter to make it like different steps so that they can make sure they've got each step done. Approach the problems that way. Use some sort of logic to break them down, because otherwise it's like looking at a great big giant word problem in a math class where if you don't know how to break it down, it's kind of overwhelming. Okay, we've got our order by clause in here. And I'm going to try running it. Oops, it says assign hours as calc assign.
You don't have a from statement.
We don't have a from statement. And I'm missing a comma there. Comma. From. Where do we want to get this from?
Assignment.
All of it? We definitely want to start at our assignment, don't we? We're looking at information from the employee and the project. Those are both on our assignment table. So yeah, it doesn't look like we need to join that to any other tables at all to get that information, just our assignment table. That looks better. But it says that we're supposed to round that to 2 decimal places. But this example doesn't show it rounded to 2 decimal places. Do you think we really have to do it?
I think you still need to round it because it doesn't work.
Does it not work? Darn, I was hoping we could get away with it. Okay, let's figure out how. SQL round. Oh, that doesn't look too bad. It says that it's a function. So the round function would require the number we want to round. So that should be our column name. And then a comma for the number of decimal places. So I should be able to put that here. Round. And what I want to round is the number that comes from the result of that calculation. And I want 2 decimal places. That looks better. So when we're using functions like this in SQL, we can put this round function like anywhere in our code we want, but it generally makes sense to put it in our select statement because that's where we're kind of formatting our data. Now my order by assignment number looks good. I should have it outdented. It shouldn't be indented like that. But then I'm going to go ahead and run it since I made that change and then make sure it works. Yay. Great job, great job. Number 6. How's our home team here? Hi, Chelsea. Yeah, it'll be up to 26, but we'll see as we go. All right, problem number 6. We have our assignment table again, and we want to get some different stuff from it this time. We want to know the total number of hours worked for each employee and the total charges stemming from those hours worked, sorted by employee number. So I've got emp num, emp last name, sum of assigned hours, and sum of assigned charge. So for this query, we're going to have to do a sum function. Again, it will go into our select statement just like the round function did. And we're going to specify that we want to create output columns that are sums of some of our columns. So let me get here to the right one. We want from this, for this one, we are going to have to look at both the employee table because we have to get their last name and the assignment table to get their hours and their charge. So we are going to have to join those two tables in this one to get the results that we want. So let's start with that. In our from clause, let's say we want to start at our employee and we're going to join our assignment table on the employee. Whoops. I tried to select it, but I just got rid of it. Employee.empnum equaling the assignment empnum. Okay, so our join is going to look like that. So for each of our assignments, we want this information. Now, in our select clause, the first thing we want is our employee num. So select employee num, and then our employee last name. And then we want our assignment hours. And our assigned charge. Now I'm going to clean up this query and get rid of this calculation because we don't need that for this query. In our sort, we want to order by empnum. So I've got the pieces all figured out that I know how to do. But for my assignment hour and my assigned charge, I need a sum, not just the individual. Let's run this and see how it differs from what they want. Column empnum in the field list is ambiguous. Remember, that means that empnum exists in both of our from tables, and the query manager needs to know which one do you want to refer to here. Do you want to refer to the assignments empnum or the employees empnum? It shouldn't matter which one we pick, but we'll put assignment. All right, so now I'm getting some results, and I see for employee number 101, their last name is News, here's their assignment hours and their assignment charge. So that looks good, but it's not what our output is wanting, because here, see this employee number 103? I have them in my output 1, 2, 3, 4, 5 times, and they're only showing one time in the desired output with a total of the hours. So I can use the sum function. So for the assignment hours, I want a sum. Just like a function in a programming language, I'm going to put the function name and then the data that I want that function to apply to within parentheses. Now this sum is going to be called sum of assign hours, is what they have the synonym set at. And then we want to do the same thing for the assignment charge, sum the assignment charge as sum of assign charge. Now that we're using that sum function, we should see that employee 103 gets summarized. We are not going to see all of the detail information for that employee. We'll only see a summarized line item for them with everything kind of summed up together. Let's check and make sure. Whoops. Oh, okay. So when I added in this sum thing, it's like I can do that. I can do this summary, but I can't give you a separate line for each emp num and emp plus name because the query manager doesn't know that those are basically the same thing, that they're on the same table. You know, well, we've actually said they're on different tables because we wanted to get the employee number from the assignment table and the last name from the employee table. So we're going to have to add a new clause, and that's the group by clause. I'm going to put it between my from and my order by, because that's where it has to go. And my group by clause specifies grouping for these summary type queries. So in this example, I want to sum the hours and the charges. And how do I want them summed? Well, go ahead and use the assignment emp num and the employee last name. So I'm basically telling SQL Server, I just want one line for each of these. I want you to group this output so that those sums just show one line for each unique combination of emp num and emp L name. Now I should have some better results. And sure enough, I see that I've got 101, 103. Need to do some rounding again, huh? Now it looks like in the output, the sum of assigned hours, they rounded to 1 decimal place. So let's put that in. Now I just want 1 decimal place. So I'm just wrapping that sum function in the round function. Now I'm going to do the same thing with my assigned charges. I'm going to wrap it round, come to my closing parentheses, and add my comma, 2 decimal places. That looks good. Does that look like what they want? Now we're seeing employee number 103 has worked 19.7 hours total on all of their assignments. And this is their total charges for all of their assignments. So by adding the group by, we allowed SQL Server to just generate one line for that unique combination emp num and emp last name. What's it want? Do you see it?
Probably the name.
Do I?
It's the names that you transfer some of.
Does it not like them? Do you see a typo?
Yeah, you have a capital F on your sum of assigned charge.
Ah, thank you. Like, it's beautiful. What could it possibly want different? You don't need me. Got this. Speaking of, let's check this one. This one should go pretty quick then. We want to create a query to get our total number of hours chart and charges for each of the projects represented in the assignment table, sorted by project number. So if I look at my ER diagram for my projects, again, in my assignment table, I have that project number. So I shouldn't need to do any joins on this one. I'm going to clean it up. In my select statement, I want my project number and my sum of assigned hours and my sum of assigned charges from assignments. I don't need my on clause. In my group by, I just need to group by this project number. So I'm going to group by any column that does not have a summary function applied to it. And then I want to order by project number also. So project 1518, that looks good. Looks good. Got it? Now remember, these are saved for you in your Cengage stuff, but if you want to save these examples someplace, you know, copy and paste them into your OneNote or however you want to do it to keep track of these examples. All right, problem number 8. This is the last one on our first assignment. Our second assignment goes to problem 26, so we're going to see how far we make it, huh? All right, write the SQL code to generate the total hours worked and the total charges made by all employees. Oh, wow, this one is actually pretty easy, isn't it? So I want to look at our ER diagram first. Whenever we look at our assignment table, we have our employee number and we have the hours and charges. So we should be able to get this information just from the assignment table. So what I can do is I'll just get rid of the project number from my select statement and only select these sums from the assignment table. I don't need a group by clause because the only thing I'm displaying are my summary items. And I can't do any sort of sorting because I should only have this one line of output that's the total. So let's run it. 90.6, 76, 12.64. Looks great. Oh, it's mad at me. What did I do? Some of. I can't see it. Some of. That's mean. Some of. I couldn't figure out what in the world Jacob was talking about. What? Some of. Okay, copy and paste is always good. Woo, that's our first one. Let's keep going. I'm happy. You guys have a submit button?
I don't see a submit button. Click on tasks on the side where the little book is, and then right below it's tasks.
Aha, submit that 100%. Thank you, sir. Confirm. All done. Make sure you didn't miss any. Okay. So we have to go out and then come into our next one. It's thinking about it. Go backwards. Okay. Page 1 has all of the information. For this section, we're going to be looking at the Saleco database. So bring it up here. This is the one that has the customers, invoices, line, item for the invoice, products, and vendors. So we just go across the row and we have all of those different pieces for our Saleco. Again, if you want to grab a snip of this while we're here, that has more of the data and everything to put on your OneNote, you can. But I'm not going to fight with mine right now because I'd like to get it more readable. They have a note here that any queries that reference US dollar values should be rounded to 2 decimal places. Write a query to count the number of invoices. Well, we saw that we could do a sum in our select statement. We can also do a count. And a count sometimes when we're looking at query results is just what we need. We just need to know how many of them there are. We don't really need to know what they say. But if we need to know how many invoices there are, I could put invoice, the table name, inside my count specification, inside my parentheses, or I can put also an asterisk. Now, sometimes we'll have to really be specific about what we want to count, and we would have to put that column specifier. But for right now, we can just say we want to count the thing with the star. And what do we want to count? Our invoices. So that should be all we need. We're just going to select a count of our invoices. It says we have 8. I hope that's right. We'll check. Yes, yay. So we can do a sum, we can do a count, we can do minimum, maximum, a lot of different functions in our select statement on our columns. All right, problem number 10 is real similar. Write a query to count the number of customers with a balance of more than $500. Okay, so I don't want to go from invoice, I want to go from customer. And it's CUS_balance. So from customer, where our balance is greater than 500. So remember, we always use our where clause to limit a result set. And since they only wanted to count customers with a balance of more than 500, we just simply put that in our where clause. And we get results that we have 2 customers. So perfect. Okay, number 11, generate a listing of all purchases made by the customers using the output shown as your guide. Sort the results by customer code, invoice number, and product description. Okay, let's look here. We need to get customer code, invoice number, invoice date, product description, line units, and line price. So let's see what all tables we need to access. Our customer code is on our invoice table and our customer table. We don't need any other columns from our customer table. So our invoice table has our customer code, our invoice number, and our invoice date. And then our line item has the invoice number and the product code to connect that invoice to the individual products. And our products table has the description. So we're gonna have to go all the way over to it to get that description. So let's see what we could do here. I'm gonna start out with my from clause. So I wanna start at my invoice. And then I wanna join my line table on invoice number. So my invoice number, INV underscore number, needs to be equal to my line table's invoice number. So now that's going to say for this invoice, here are the 3 line items that match it, that use that invoice number. But now I have to also join the product table because I want to get that product description and I can't get it any other way. So I'm going to say to join that, I want to use the line product code and wherever it is equal to the product code, I want to get those records. So that looks good. I think that that's going to get me where I want to go. I'm going to start on the invoice table and I'm saying take that invoice number and match it to all the line items. Then for each of the line items, take that product code and match it to the product record so that I can get the description. Does that make sense? We've got to get to each of those tables to get to that data. So what we want to select first of all is CUS code, invoice number, invoice date, product description, and our line units and our line price. Now I'm going to run that. I don't have my sort in yet. I'll go ahead and put a semicolon and run it. Now, the first error I've got is that the column INV number is ambiguous. What does that error mean?
Doesn't know which inventory number you're talking about.
Exactly. So which invoice number do we want? It doesn't really matter. Let's take it from our invoice. Now we're getting some data. It doesn't look like we need to do any rounding. Everything looks okay rounding wise. Our invoice date looks okay. So we just need to add in our sort. Let's order by CUS code, INV number, and product description. Are we going to get that same ambiguous message on our order by? Let's check. We don't because we resolved it in our select statement. So it's going to use the same invoice number it used in the select statement for the sorting. So now we should match exactly. We have our customer code, invoice number, invoice date, and our product description. Our rat tail file comes up first. And customer 1004 has 2 invoices or 2 different products they've bought. So I think everything looks good. Woohoo! I want some of that confetti thing like you guys get when you turn in your assignments on Canvas. Some feedback. Using the output shown as your guide, generate a list of customer purchases, including the subtotals for each of the invoice line numbers. The subtotal is a derived attribute calculated by multiplying line units by line price. Sort the output by customer code, invoice number, and product description. Be certain to use the column aliases shown. Okay, so what do I need to change here? First of all, I want a list of customer purchases. But it looks like I want the same kind of information. My customer code, the invoice number. Okay, we don't need invoice date, so I'm going to get rid of that. Our product description. Now, line units, we want that to be known as units bought. And since I'm going to have a space in that, I need to delineate it with the square brackets or double quotes, either way. And then my line price is going to be as unit price. And then we need a calculation. We want our subtotal. They say we have to multiply our line units times our line price. And that is going to be subtotal. So I don't think we should need to change anything else. Our join should be good. We're going to our invoice, getting our product information for that product description. Our order by information is correct for what they want. We might need to do some rounding though, so let's check. Units bought as unit price.
Yeah, I think we need to round the subtotal.
It doesn't like our square bracket. Are we gonna have to do double quotes? Yeah, we'll probably have to round. Their emulator thing might not be able to handle the square brackets. That's what it was. So square brackets should be okay, but it's not being able to handle them. So we can handle that, but we need to round our subtotal for sure. So let's put that in, round that formula. And I need another set of parentheses then. So I'm going to put my formula within the first set of parentheses and then the comma 2 within the second set. Now, does everybody look happy there? It's good. Number 13, write a query to display the customer code, balance, and total purchases for each custom. Mine doesn't like my order by. You want to show us, Jackie? Let me stop sharing. Show us what it's telling you. Yep, we can see it. Okay, so let's see your order by code that it doesn't like.
That's an extra semicolon.
Oh, extra semicolon. Good eyes, do you see it? Right there. Woohoo, good job. I was not seeing it. Okay, I'm booting you. All righty. So for third, oh, Garrett's is also not working. He's yelling at us. He apologized. I'm just kidding him. Okay, Garrett, show us what you got. Let's see it. Let's see it.
Can you see it?
Yep, we can see it.
I think I figured out what it was.
Oh, yep, double quotes. So close your double quotes for your unit spot. And then put double quotes around units price, because it just doesn't like those spaces. That should do it. Yay. Awesome. Okay, so for this one, we want to sort by customer code. Let's see our database here. So for our customers, we want to know what their balance is. Where are we going to have to go to get that? We've got a customer balance field on our customer table. Total purchase is calculated by summing the line subtotals as calculated in problem 12 for each customer. So we are going to have to take our customer and join that to our invoice. And we're going to have to join our invoice to the line table to be able to add up all of those things that they've bought. So let's start out with our from clause. We're going to start from our customer. And our customer, we're going to join to our invoice on our customer dot customer code being equal to our invoice dot customer code. So our invoice is carrying that foreign key because we have many invoices for each customer. Then we're going to join our line table on invoice dot invoice number equal our line table. Whoops. Invoice number. Now, as we're finishing this one, this is number 13, and our assignment was to go out to 26. So what I'll be doing is changing that assignment to end at 13. So this will be our last one that's due today, and then the rest of them will be due next week for this week's assignments. So we'll keep ourselves in track. All right, so my from clause I have pretty well situated. From customer join invoice, join the line item, and then I want to update my select clause. So I do want my customer code. The next column that I want is my customer balance, and then our total purchases. And that's going to be a sum of line underscore units times our line price. Now, do we need to give that a different name? Yep, that is going to be as total purchases. Now, in this example, because we're doing a summary query again, we have to add the group by. So our group by clause is going to specify all of the columns that we're not summarizing. So cus code and customer balance. And in our order by, we just need the customer code. Now I might get some ambiguous errors. Yep. Because our customer code occurs in so many of our different tables. So let's say we're going to use our customers' customer code. Now in our group by clause, we saw that our where clause was smart enough to not have to worry about that ambiguousness, but our group by is not. Okay. Does it work? Woohoo! Let's save it. Oh, I've got something it doesn't like. You are welcome, Chelsea. Okay, I'm going to update these assignments. Be aware that I could screw something up and we could have to do something different.
Yeah, you just need to round it.
Just round it. Ah, yeah, look at all those zeros. See ya. Get out of here. Great job. Wednesday, we'll talk about summary queries and do a bunch more. So practice, practice, practice. We'll get these out of our way. Jackie, you shouldn't have invoice number.
Do we need submitted still?
Yeah, go ahead and submit it and I'll resolve whatever issues we come up with. If we have to submit it again, we will. So. Total purchases. I need to round. Is that gonna fix it? There we go. Yay. Did you put in the rounding, Garrett? Make sure you round it. People are still talking to me, sorry. See ya. Have a great day. This mask just requires too much adjusting.
Yeah, every time I yawn.
It's like those other ones, I just don't know. Oh. Could spend a fortune on masks to try to get one that you love.
Yeah, I like this one. You can like bend the nose piece so it stays attached to your nose. More.
Yeah, I bought some of the little separate ones. Send Gage, they'll be like, well, you shouldn't have had him submit. Well, you should have had him submit. I don't.
I have a problem getting my postal to submit. It says it's 0% done, even though it says everything.
Oh, nice.
Mine scared me. It said your session is timed out, and I'm like, oh no, please don't close out of it.
Well, I feel like we should be saving them somehow, you know?
So what I do with mine is I write like problem number, and then when I finish the problem, I just comment the code out.
Let's close it. Do you? I think that's a good idea. I think we should start something though. We need to do something different. We need to keep them. We will do that next time. Here. Well, I can tell when I'm doing the work. I can tweak each problem that we've done. So I'll see what kind of state you're in. So don't worry about it. I think I'm going to get them all messed up anyway. So I could probably just make a giant mess. What's wrong with yours? Check the manual. I love that. That's so mean.
Yeah, so you got it wrong, figured out. We're not gonna tell you.
RTFM! Can't say that in school. Switch your summon around. I think your sound has to be outside.
I don't know, but yeah, I don't know how that happened. Yeah.
Oh, because you want to round your song. I don't know if that's the problem though. Now, do customer dot. And then give them an order by.
Did he do it?
Oh, you put it in the online. You put customer on your test code, not your test balance. Oh, because I'm sitting over your shoulder. Thanks, babe. See you tomorrow.
There's so many small things that you can do wrong with your queries, and it's like, what did I do?
I know, it's so like crazy. You get used to some, and then it's like, why do we have to have new books? Never get new books.
Just 9 to 13 for the second part.
I hate getting new stuff ever. The CIS250 class is all Excel and Access. This one module is just really, really hard, and it's really cool because it shows you how to do like a 3D map where you can make the map into a graph, and it's so cool. And all of the tools have been replaced like by this Power BI thing. And so it uses Silverlight. So this semester was just a total disaster because nobody could get Silverlight installed or anything. And so I'm calling the help desk. I'm trying to use the remote desktop, and it just keeps hanging. And the guys are like, well, why are you making them use something that uses Silverlight? Well, because that's what they're supposed to do. It's really cool. It's super cool stuff. It looks like the Power BI stuff that has replaced it would be like a semester-long class instead of just one module. Way too much excitement though for things changing, getting out of date.
Yeah, really with any technology, you can't get comfortable with it.
So I have all these Excel people just wanting to come kill me. They're like, why are they looking at do this crazy? Well, you could have, but you would have worked hard enough that you could do it on my computer. I got it to work somehow.
What's fun is like looking up tutorials because I like have the software on Mac, and then it's just like totally different.
Oh no, that's awful. Yeah, it's totally different.
That's why sometimes I just use Windows for certain things.
Mm-hmm. Yeah, sometimes it's just the easier way to go, even though you hate to. Just easier.
That's why I need to get like something like a switcher for my keyboard and mouse, and then just like have my laptop and